Next, we want to make our movement task. And remember, we want this to be generic, not specific to our weighted platform. So we need to consider how we want to put that together. So let's make a new task. So right next to our get overlap actor count, let's right click and we'll go to blueprint class. We'll type in state task, the state tree task blueprint base, select, call this STT underscore move to pause. So move to position, Control S to save it. Open it up. And again, we want to think about what are the different things that we need. Now, if we're moving an actor, I think we're going to need reference to the actor and the actor's location. So let's click a new variable. We'll make our context. We almost always want a context actor. So we'll just call this actor. We'll change it to actor. So actor object reference. We really don't need the more specific weighted platform yet, which is good. We want this to be generic. Compile, save. And we want to mark this as context. If this is our context actor, we need to put this category in. So double check your spelling here. So context, capital C. In order to move something, we probably also want a target position. So where are we moving it? What are we moving it towards? And let's make a variable for that. And if it's something required, we probably want that as an input. Let's call this target POS, and this is going to be a vector since it's going to be a location. Compile, save, and we're going to mark this category as input with a capital I. Input, make sure you spell that correctly. Okay, so we have our context input, and usually when we're moving something, we also want a speed. So if we have a target position and a speed, then we can probably reuse this task in a lot of different ways. So let's make our speed, hit plus, let's call that speed, make that a float. And the interesting thing about speed is that we probably don't need it to be required. We can set a default value and then they can customize it if they want. So I think I'll do it that way. And the way to do that is to click this editable button right here. This means that we can edit it when we are assembling the state tree. So inside of the state tree editor, we can put different values, whereas input means that we have to. If we just want to keep the default right here, we can. So I'm going to mark that as editable. I think that makes sense. Compile, save. Let's make the speed, let's give it 1 as a default just in case. Compile, save. So let's override a function. For anything that involves movement over time, you're either going to want a timeline or a tick. And since we're not really dealing with timelines inside of tasks, like I don't even think we get access to it, but I'm not positive. I don't see anything here. So we're just going to move it in tick. And I think that makes sense. Like that is one of the few times where it is appropriate to use tick. I'm going to override tick since we haven't done that one yet using delta time. So over time, we're going to move our context actor toward a position. So to do that, we are going to use our, I think it's called interp to constant. Interp to constant. Yeah, so vinterp to constant. This node, if we give it our current position and a target position and then a speed, and then we plug in the delta time, we can move it towards a position. So let's give it what it wants. The current position is our actor. So get our actor, our context actor, get the pull off and say get actor location. This is the location of our owning actor. So that's our current position. And then our target position is whatever we sent in. So that's going to be our input. We know it will be assigned, so we can rely on that. I can pull it in and get, but I'm just going to pull it directly into the target like that. Okay. Let's plug in our delta time and we need our speed. Let's pull in our speed right here. Pull that in, compile, save. You know what? I think this is going to be a very small speed. I'm going to bump this up to like 100 by default. I think is fine. Okay. Compile, save. So this will return a new position moving towards the constant, but we actually need to move the actor using that position. So in order to do that, let's right click up here and say set actor location. Oh, we actually need to pull off of actor, I think. So I'm going to copy paste it over here just to make my lines clean. Pull off and say set actor location. There we go. I'll pull that and then let's pull this over. That. Plug in the execution pin. The new location, this is going to be what we calculated. So we're moving towards the position. We're getting a position moving towards it. So we need to move to that new position. And we're going to keep moving every frame using the speed. So this does the calculation. This actually moves it. We might want to sweep just in case we hit anything. I don't know. We don't really have to do anything with that for now. Let's just move it closer if possible. So this is our movement code. We're moving towards a position. The other thing is for this task, I want to call a finish task function whenever we actually get to the target position or when we're close enough that it doesn't matter. And I will show you what finishing a task means later on. For now, it's just important that we actually know when we've reached our target location. So we're going to do a check. We're going to move the actor a little bit towards the target position, and we're going to check the distance. So to check the distance, get our actor, get actor location, pull off of this and type in distance, because we want to get the distance between two vectors. So click distance vector, and we need our target position. So the current position and the target, want the distance between those. So pull in our target position for the other one. Okay, now if this distance is less than a certain amount, we could call that the target threshold maybe. So you know what, let's promote to variable, and we actually don't need to set that there. We'll just keep the variable that it created, and we'll call this target threshold, compile, save. We can actually leave our default value at 0. Maybe by default there's no threshold. We just want to know if we've exactly hit it, but we can make it so that if it's close enough, right? So if it's within 100 units or something, we could change that. So I'll click the little eyeball right there if the designer wants to modify that anytime they use this task. If our distance is less than or equal to our threshold, then we've done it. So pull off of return value of our distance, less than equal to, not 0, we want our variable. So if it's less than or equal to our target threshold, then let's determine that we've hit our target. So we could just pull off of here and branch off, but I'm going to save this into a Boolean that we're just going to update. Let's make a variable. Call this has reached target. We'll make this a Boolean. And we want to hide that, so not editable. And the reason I'm doing this is because we can also later on do a check that if we've reached the target, then don't run the movement calculation. Maybe it'll optimize it slightly. So if we have reached the position and we've done our check, let's pull off set has reached target. Okay, so our Boolean, we could pull this off and set it, or we could just type it in like that. Let's set this and say, yes, we have reached our target, or if we haven't, right, if it's not less than or equal to, then I'll mark it as false. We have not reached our target. But either way, it'll set it appropriately. So let's pull that up, connect it, compile, save. And the last thing I want to do here is I want to show you that we can finish a task, which will mark this task as complete, which then we can use for transitions for on-state complete, how we're doing with the delay task. When we count 1 second, it gets marked as complete. We can run that function inside of our own blueprints to tell it when to mark as complete, if we want to at all. So let's check it. Let's say we have set our has reached target. Let's pull off of this and say branch. If we have reached our target, right, if our condition is true, type in finish task. So finish task is a part of our state tree task class. If we call this node, we can mark a task either succeeded or, if we want to, not succeeded. I'm going to mark this as succeeded so that we can see what that does later on when we're going through our transitions. But this means when we complete this task right there, then the state tree can listen in for that, and we can use that for transitions if we want. Compile, save. Now, before we actually use this, I want to clean this up a little bit, because all this over here, we probably want to check this, for example, right when we start, like at the very beginning. If our target location is exactly where we are already, then I don't want to move the actor or do any of this stuff. So I think it makes sense to turn this into a function. A really easy and quick way of doing that, you just highlight all of this, right click and say collapse to function. Puts it all inside of a function and makes it, puts it all in there. Let's call this check if near target. Compile and save. So super quick cleanup, pull that in. Let's go inside of our function just to be sure. Okay, great. Pull that out a little bit, move it over. Okay, and the nice thing about this is that I can also call this. So when we go back to our event graph, we can call this when we enter the state. So let's say override enter state. Let's pull that up. So when we enter our state, let's just check if near target. So we can pull this out, check if we're near target. And if so, then we'll mark our task as completed and we've never even run our tick function. Compile, save, and I think this is good enough for now. So we're moving our actor's location towards a target position. We have our variables marked appropriately. We're checking if we're near the target. And if we are, why we're checking the distance. And if we are near the target, we're finishing the task, which we can then use in our state tree in different ways. So this is our move to position task. And the nice thing about it is nothing is specific to the weighted platform. We can use this in other state trees, and it's just a handy little task that you'll be able to use a whole lot. Before we can actually start using our move to position task inside of our weighted platform, we need to think about how we're going to actually use it. So for example, in our weighted platform, when we are inside of our level, if we're rising, we want to rise to a certain position, right? So we need to track, let's say, our starting position, and we're going to rise to our starting position, and then we'll check if we're near that to determine if we're back into idle. And if we're sinking, we want to determine a sinking position to determine when to stop. So I think for my weighted platform to work, I'm going to need to define a rise position or maybe a starting position and a sinking position. So we're going to put that on the weighted platform because we don't need to know about that in the move to position task, right? This is just moving the object and that's all it cares about. Now my state tree will care about, what's your target? What are you moving towards? So we're going to put that inside the weighted platform itself as a variable because we may have different weighted platforms, and I'm just going to pull these out right here. So let's duplicate a couple. We may have different weighted platforms, and each one might have a different sinking position, right? So we don't want that to be built into the state tree. We want that to be defined on each individual platform. So we're going to put that on the blueprint. So inside of my blueprint weighted platform, we're going to determine a sink location that we can then get a world position that we can use as our target position for our task. I could make that as a value that then you could put, what is the value you want to sync to? But I think it would be nicer to have a little icon that we can drag down and be more designer friendly. So let's do it that way. I'm going to go into my weighted platform and let's make a component that is just an empty scene component. So we'll say add, and we'll type in scene. This bottom one. So this is a component that is just an empty point in space, and we can move it around. But the nice thing about it is that we can, move it, and then the designer can choose where exactly it wants to sync instead of worrying about numbers over here. Like they may not know how far 280 units is, right? So I'm going to undo that. Let's rename this scene component to be sync location. Let's compile and save it. And the nice thing about this sync location is if we come back into our scene, inside of the level, if you click on this platform, inside of details, you can actually select, if you scroll down a little bit with your middle mouse, this sync location, you can actually pull it down, right? You don't want to pull it down too much or you'll go into the floor. I don't have any checks for like stopping before collision. So let's put it pretty close to the floor right about there. And you could do that with the other platforms too. I think it's honestly going to be quicker to just delete them. And now that I have this one set up, right, with our sync location down there. Okay, so let's duplicate the actor, come over here, make sure you're on the root over here. Otherwise you'll duplicate components and you don't really want that. Hold Alt and pull it out again. Again, have the root selected, otherwise you're duplicating components. So we should have 3 different actors. And the nice thing is each one, its own sync location, right? But we can actually vary these. So maybe this one we want to be like a smaller sync location based on where it is in the level. So you can see they're independent, which is nice. So I'll just leave that there just to show you that they can be different. Okay, so let's save that. And we have our sync location, but we actually need to take this scene component and our starting position and then turn those into vector3s that we can use as variables and pull into our state tree because we need a target position, so an XYZ. So to do that, we're going to go to the event graph inside of our weighted platform. And in begin play, let's actually remove the other ones. In begin play, right click, get actor location. So when we begin, we're going to save off our starting location. Right click the return value and say promote to variable. We're going to set this. So get actor location and begin play. We'll call that start, pause, pull this up, connect it. Now this says target self. That's fine. If you don't define a target, it'll default to the self, but I'm going to pull off and type self. I usually like to be explicit about that. Compile, save. And the other thing we need is we need to save off the location of our sync location. So let's pull off of that. So sync location, pull off, say get world location, right? Because we want to save the sync location when we start the game, because when the object starts moving, the current sync location might get dragged along with the object. We want it to be set in space. So we're going to do this in begin play, get the positions, save that off, and use those to return. And then we're going to right click return value, promote the variable, so the world location at begin of our sync location component. Set that one to, and relabel that sync pause. Okay, compile, save. We may want to determine our speed inside of the weighted platform. So our task doesn't care about the speed, just give it a speed and it will do its job. We want the weighted platform to manage its own different speeds to send into the state tree. So let's say a sinking speed and a rising speed. So let's define those over here inside of the weighted platform, and we'll pull those variables into our state tree. So variables, let's say, make a new one, plus sync speed, and make that a float. Let's just duplicate it just because it's faster. Control D, rise speed. And the reason I'm doing this is because I may want our platform to sync faster than it rises, right? Like maybe that's a design mechanic thing so that it doesn't break our level, or we can just hop on platforms to bypass things. The designer might want controls. So let's define it separately, compile, save, and let's set up our defaults. For our sync speed, let's make that, I think 100. I think that's also our default in our movement. And our rise, let's make it rise slower. So let's put that at 50. Compile, save. So we have all our variables set up on our weighted platform, which then, we could customize. We could have different kinds of weighted platforms, but then we can send in the variables into our state tree. That way we're keeping everything very modular and generic. All right, now that we have everything we need, we are ready to plug it into our state tree. So click on syncing. While we're in syncing, we want to run a task. So hit plus called STT MoveToPos. That's what we just created. And in our STT MoveToPos, our actor is our context. So we don't need to worry about that. It gets plugged in automatically because of the context keyword. Our input is our target position. So we could put one right here if we want, but I'm going to bind it instead. So at the plus over here, our target position is inside of our actor, right? Because it's our context, we get access to the weighted platform variables, which is nice. And our target while we're syncing is our sync position. Okay, so we're moving towards our sync position at a certain speed. We could plug one in here, or we could let the weighted platform define it. So go to actor again, go to sync speed. We can change a target threshold if we want, but I'm just going to leave that alone. Okay, and then also when we are rising, we want to run our task. So click on rising, click on task. And we want our target position to be our starting. So click the little bind over here, go to actor start position. So rise back up to the start position. Our speed, we've already defined that on the actor. So maybe the designer chooses that. We're just setting it up. Rise speed. Again, target threshold, we can just leave that at 0 if we want. Compile, save, and let's test it out. Now it's actually going to get stuck and I'll show you why. But for now, we just want to see if it moves. Hit play. Okay, it moves. But look, we get stuck at the bottom and it gets stuck in idle, right? We actually wanted it to go to rising. So I want to think about why does that happen, right? Why does it get stuck in idle? And the reason is because our transitions are not set appropriately. Right now, while we're syncing, we're detecting if on tick, if our actor count has changed. If we sync all the way to the bottom and inside of our task, it gets marked as complete and we have not met any other transition conditions, it'll just go back to the root, right? Because we haven't told it to go anywhere else and didn't meet these transitions, completed its task, it's going to go back to the root. So instead, we want to be more explicit. In syncing, I'm going to add a new transition. So syncing, hit plus, and our new transition is going to be on state completed. So if we complete our syncing state, we're going to go not to root, we're going to go to rising. So let's try it now. Compile, save, go back. And there's going to be another issue, and I'll show you if it goes all the way to the bottom. See how it's alternating between syncing and rising? Well, you can probably reason through why. It gets to the bottom, so we're syncing, then we're rising, but we still have an actor on it. So we're syncing, and then we're rising, then we're syncing, then we're rising because we're down at the bottom. We just get trapped in these two states. So now we want to figure out how we can make our platform pause at the bottom after we move while we're syncing. The reason that we're having our issue here is when we're syncing, we actually have two different things that we want to happen. We want it to move, and then afterwards, we want it to wait, right? Like we don't want to do both of these things at the same time. We want to do them one after the other. Anytime you have a sequence like this, you usually want to break this up into multiple child states. And there's a lot of ways you can actually handle this, but putting this into separate child states gives us a lot of flexibility. And I want to show you how you could do that. If we want to take our syncing behavior and we want to break that up into multiple different states, find our syncing state and right click, go to add state. We're going to make a child state. We're going to call this first one move. Right, so we're syncing move, and then we're going to click again, right click, add state, child state, and this one we'll call wait. Now, right now they're empty, so we're going to break this out. We're going to take our movement task and we're going to move it to our move over here. So I'm going to delete the movement task that I just created. So right click and delete. Maybe they'll have a better copy paste feature eventually, but right now I don't like the one that's there. And go to our move and we'll just add the task right back. So under move, we'll go STT, move to position. And then this is our task. We'll run. Again, we're going to set our target position to bind to actor sync position. And then our speed, we're going to bind to our actor sync speed. It's important that you removed it from the parent and then added it back to the movement child state. The other thing that we need to do is we need to transition from move to wait. So right now our on state completed is still on our parent. So I'm going to remove that one as well. So on our syncing parent, the on state completed. So when we finish our tasks, move to rising, we don't want that to happen. So I'm going to right click and delete. We're going to keep our other on tick. That's the one detecting actors. We still want that on the parent, but on move, we're going to add our transition back. So when we finish moving, we want to go to wait. So on state completed and move to transition to wait. And we don't really need a condition here because as long as we complete our task, we want to transition. So that's fine. And then the last thing is on wait. We want to add a delay task. And just to show you that there are reasons you might want to do this, you can just run forever. So I'm going to click the run forever, delay forever. Now, the reason why this works and the reason why I'm not really going to get stuck is because I am still checking for my on tick if our actors ever change and we don't have any actors and we can go back into rising. Since it's running on the parent, this transition is still checking, right? So the parent transitions will always be checking. The child is just waiting forever. So all we're doing is we're checking on the parent. So it's not quite the trap that it seems like it is, but make sure that if you ever run forever, you have some other thing above it that is checking a transition or a condition somewhere. So we can just leave this how it is. Since the default will go back to the root and that's fine anyways. We're going to wait here. And then whenever this syncing transition checks, then we're going to go to rising. So all I did here is I separated out my movement behavior from my wait behavior, and that gives me more flexibility since I can run one after the other and I can decide where I'm going to transition. So let's compile, save, and let's test it out now. All right, let's test it out. We are going to our platforms. We're syncing, rising, syncing, rising. But if we wait at the bottom, we're staying syncing, and then we're rising. We're back at the beginning. Okay, great. And you can see this one has a smaller syncing, but it still works. That's fine. So we have some customization and we have our movement functional. Great. And I did want to show you one more thing. What's happening in rising, when we complete our movement task, we don't really have a transition defined down here. So like on state completed. So when it's done, it is just going back to the root and then it's ending up in idle. Now we can be more explicit with this, which is what I'm going to do because I don't like that it's just not defined and that could kind of hide behavior and I don't really like that. So I'm going to add a new transition in rising, even though it's perfectly functional without. I'm going to prevent future bugs if I set it up this way. When our state is completed, so when we're done moving while we're rising, we get all the way back to the top, we can just transition back to the root. I think that would be perfectly fine. Or we can transition back to idle. I'm going to put it to idle for now because it's going to show, some other weirdness later on that we'll resolve, but I don't like that it's returning to states and I don't have a transition defined down here. And I'm just going to put this here to make sure that we understand what's going on. So just kind of a minor thing, but I think it's worth pointing out.